Right, it is 2:46, and I have so much content and things to talk about, so I'm going to go ahead and get started. Um, Thank you for coming to this talk on being able to Kotlin everything. Um, Before I jump into things, I just want to first thank the organizers, thank the volunteers of Code PaLOusa, and all these fabulous sponsors. Putting on events like this, especially in this age of COVID, is not a trivial task. So I just wanted to thank you again for allowing me, all these other great speakers, the opportunity to speak. So thank you, thank you, thank you. And now, without further ado, let us Kotlin all the things. So who am I? If you don't know me, my name is Michael Yodev. I'm a software developer and instructor for Big Nerd Ranch. If you haven't heard of Big Nerd Ranch, we are a web and mobile app development agency who also offer expert training. I love my job. I really do. I literally get to practice what I preach every day. Practice what I preach. And today I want to talk to you about Kotlin. Why Kotlin? Well, it's not just because we have this fantastic book, which I highly recommend. Sorry, I cannot help but use this opportunity to mention that we have a book on this topic. But my passion is Android development. And you have to understand that before Google made the official announcement in 2017 that they were officially supporting Kotlin for Android, developing apps on Android really wasn't great. Like, it was fine, but like we had this Java hurdle, and not even like cool Java, like it was Java 6, and this was 2016, 2017. And then along comes Kotlin, this modern, pragmatic, industry-built language that Google has given their blessing that we can use. And all of a sudden, Android development changed seemingly overnight. So a lot of that ceremony that came with that Java feel, the enterprisiness of the JVM, just completely fell away, and the developing experience just immediately improved overnight. I was, needless to say, hooked. So I did what any passionate developers would do. I joined up with some other Kotlin enthusiasts from my local area, and we formed a Kotlin user group, the Columbus Kotlin user group. And we would meet every month for a little over a year. And talked about various aspects of Kotlin that we liked, the language, features like coroutines, and a whole lot of Android stuff. But it wasn't until like the end of our time together that I realized that there was a huge aspect of Kotlin that we never really got into. Kotlin isn't just for the JVM. And it was that realization that led to me writing this talk. So JetBrains, the creator of Kotlin, creators of Kotlin, I should say, designed the language to interface with a lot of different platforms. Sure, at the beginning, their goal was 100% interoperability with Java, but they designed it in such a way that you could utilize Kotlin for really everything. Now, why? You might be asking yourself, which is a perfectly natural response, why would you want to write applications in one language that work on desktop, mobile, web, so on and so forth? Well, we're already in this world of single language cross-platform development. If we think about tools like React Native and Flutter and many other cross-platform tools, why are these things so popular? Well, cost is one thing. People are expensive. If I need to hire one dev for Java stuff on the back end and one dev for JavaScript and one dev for Android, like it starts to add up in terms of cost, especially if I'm a business and organization just trying to produce quality software. Coding in one language across multiple platforms allows me to share code across those platforms, which reduces friction between teams and reduces duplication. If we could reduce duplication, that increases quality. We can gain more code coverage, which also increases quality. And then we can also be in this true feature team world that we all try to be into in our shops and centers, all working on amongst the same tech stack and being able to share code in a feature-rich environment. So for the next 45-ish minutes, I think, I want to talk about these other facets of Kotlin. First, I'll warm up with what's happening on the JVM side, but I'm going to approach it from a different angle. My background, again, I said, is Android. I want to talk about what's happening on the server side using Kotlin, because the space is way more active than what it may seem. Then I'll start talking about how we can use Kotlin on the web in terms of using Kotlin on a web browser, client-side Kotlin. And then after that, we'll look at creating native binaries with Kotlin Native and how you can leverage this for code sharing on iOS. And then finally, we'll wrap everything up on how we can manage all of these with a tool that JetBrains has provided called Kotlin Multiplatform. Okay. So Kotlin on the server side. So let's define what I'm meaning by server side. I'm talking about backend, reading dynamic data, authenticating, persisting data. These are your REST APIs, web server, chat applications, things like that. So why would you want to use Kotlin on the server side? Well, Kotlin is a great modern language, industry built, very pragmatic, and it has these great features that we can take advantage of that might not exist in your current tech stack. So we have higher order functions, extension functions, which are really cool, type safety, solving that nullability problem with null types, and coroutines, a new threading model that makes doing concurrency a lot easier. And if you're already a Java shop, Kotlin allows you to stay on Java because of its 100% interoperability with Java. Okay. Now, backend frameworks on Java are not new. There's a ton of them out there, and I don't have the time in this presentation to go over each and every one of them. And honestly, I don't have the experience either of playing around with all of these different frameworks. But there is a talk from Ken Yee at KotlinConf 2018 where he goes through and he compares all these various different these frameworks. So for this presentation, I would like to examine a framework that has a lot of features and has been around the longest. So I'm going to talk about Spring, but then I'm going to talk about a product from JetBrains called Ktor. It's not as new. I'm sorry, it's fairly new, and it has a lot of features to it, but it's still, you know, still fairly new. So I put that with a little asterisk that this is JetBrains' framework. There are people that are using it in production, but it's still new. So just keep that in mind. So with Spring is the most popular framework for building Java applications. It's very flexible, modular, and it's backwards compatible with previous versions. Its main focus and why it's so popular is making development easier by reducing boilerplate. It has a very large and active community, and even though it's open source, it has the backing of a very large company, Pivotal. And with Spring, there's all sorts of different things you can use it for. There's LDAP integrations, there's web services, which probably a lot of us are familiar with. There's cloud stuff to be able to do data, just tons and tons of stuff. So much stuff that it gets to be a little overwhelming if you're just jumping into Spring on your own. So that's why you may have heard there's this other product called Spring Boot. And this is honestly the product that I've used in the past. Spring helps you get a fully working web application up and running quickly by providing you opinions on how to build it, okay? So really, it is a version of Spring that is a more opinionated approach to building these applications. Its aim is to reduce these configurations and streamline deployments. It helps you write clean code by doing all the heavy lifting for you so you can focus more on your business logic. And I found this animated GIF, and I'm going to say GIF. I found this animated GIF to really drive this point home. So on the left, in this example, we're making lemonade, and on the left is how you would make lemonade with Spring. Okay, you would pick your ingredients, put it in a blender one by one, and hit the button. But on the right, we have Spring Boot, and we just say, "Hey, I want to make lemonade. Here's lemons," and then this processor goes out and goes ahead and figures out how much sugar and so on and so forth, all the other ingredients that you need to build it. Okay. So that's kind of the difference between Spring and Spring Boot's. Spring Boot's way more opinionated about how going about building applications. So in this example, I'm going to use the Spring initializer to quickly scaffold a Spring project. So the Spring initializer, if you go to start.spring.io, there's this fancy website that will scaffold out a project for you. So you feed it information about, do you want to use Gradle as your build system, or do you want to use Maven? Is this a Kotlin project, which in this case, yes, we're going to choose Kotlin. What version of Spring Boot do you want to use? Some metadata about the project, like what's your group and what artifact do you want to produce. But then you also get dependencies. So you can go ahead and quickly add dependencies, like if you wanted to create a reactive website, or use WebSockets, or things like that. And what happens is when you click the generate project, it's going to give you a zip file, and inside that zip file, inside the source directory, you have the basic application, the Spring Boot application. So inside this application, we have an application class where we can define configurations and things like that. And this is just a class that is annotated with the Spring Boot application annotation. And it's just this empty class that just lives out there. And then with Kotlin, we can have top level functions. So here I have my main. This is the entry point for our application, where I'm just going to say run application and pass it my demo application, optionally some arguments. I don't really need those in this case. And then what I can do is I can start defining controllers. And this is your typical MVC approach on the server side. So I create a class called Hello World controller. It's annotated with the REST controller because I'm creating a REST API. And then inside this class, I can define specific actions and methods. So here I have a mapping. This is going to be my default route. So when this application first launches, this is the route that's going to get called, and I'm going to return the string hello world. And when I run the application, sure enough, it runs in the browser on my local host, and I believe it's using Netty as its embedded server. But you have, it's using Tomcat as its embedded. But you can switch that to whatever server you would like to run it at, or whatever engine you would like to run it as. So, building on this, if we wanted to pass data to our, if we want to return data from our Hello World controller, here I'm doing the /sample route, and inside this function sample, I'm going to create a range from 1 to 10, and then map a simple object. The simple object is a Kotlin data class. And data classes in Kotlin are really, really special because you can define properties like this is a val data. So this is a read-only property that's a string that just the default value is going to be sample. You can have getters and setters by defining vars, but data classes also give you like 2 equals 2 string hash code for free. So these are quick and simple little POJO objects that really allow you to mock up your network models really quickly. So in this example, I'm just looping 10 times and creating 10 simple objects, and that's going to be returned as an array. And if we advance, what gets returned, Spring Boot is automatically serializing that object to JSON data. So here I have an array of sample data really quickly. So moving on, I want to change gears and talk about Ktor. So that was how we spin up a quick web server in Spring Boot. But let's talk about JetBrains' approach. So Ktor is JetBrains' official server framework. It's written using pure coroutines, so it's very, very fast. It's built with coroutines in mind. So that's JetBrains' threading model for being able to do concurrency. It is very unopinionated. So when you create a Ktor project, you have free reign on what you want to do. But JetBrains does provide a lot of features for you out of the box. So you can opt into things like WebSockets, authentication. There are HTML templates that you can use to quickly build out your user interface if you would like to do that from the server side. But again, this is the least mature, so when you're investigating it, when you're looking at it, just keep that in mind. Ktor can be hosted on any Serverlet 3.0 plus API such as Tomcat, and it also supports Netty and Jetty too. And bundled away, and this will come more into play later on in the talk, JetBrains provides their own cross-platform HTTP client that includes doing things like authentication with OAuth, cookie management, WebSockets, JSON processing, or you can use your own JSON processor along with it. This is still Java code. So, but that cross-platform HTTP client, file that away. That's gonna be something interesting that we talk about later. So how do we use Ktor? Well, first, we define a function, main entry point. So when we launch this app, that main is going to get executed. We say we're going to embed this in a server. And here I just said Netty, and we're going to use it on port 8080. And then we give it, this is actually a function that I'm telling it to call. So it's an extension of our application class, but this is our main function. So what does this look like? So here's an extension function off of application. So we have access to certain configurations that live within the application class. And here we're going to do things like install headers or install content negotiation, because I want to be able to send data back and forth using JSON. So I'm configuring JSON. And maybe I want to do something different with my dates, or for debugging, I want to turn on pretty printing. I can do all that configuration right here. And just for the purposes of this slide, I'm also going to be installing my routes. So here's where we're going to be defining our controller actions, quote unquote. So here's our install routes. This just lives off in a function just so I can put it on these slides. So inside this function, we have a routing block. This is just a function that accepts more functions. So here we have a get. This is going to be my default route. I have a sessions route, and I have a sessions by ID. So I'm creating a basic conference app, a conference API here, okay? So what do the details look like? So inside my default route, I have access to who's calling me, and I want to respond with HTML. Now I could just do this all straight with magic strings, but those who have ever done web development know that those can be a little bit unruly. Especially if you're trying to maintain things, especially as your application grows and scales. So luckily, the folks at JetBrains have provided us this Kotlin X.html library that provides a DSL for building HTML. And this is really, really nice and convenient for us to say, hey, what do I need to put in my head tag, or versus what do I need to put in my body tag? And you can see this DSL becomes very, very readable as we start to progress inside these tags, okay? So when I run this application, either through IntelliJ or through the command line, I get a web server that gets spun up, and here is the response. So that call responded with HTML with a h1 tag inside the body and the title of ping. And I have that here, ping, and the API is up. If I wanted to return data, and I'm sorry, I noticed this right before the talk, I didn't provide the data class here for my session, but hypothetically, say I had some sort of repository that returns a list of session objects, right? And so inside the session object, it's just a plain old Kotlin data class that has like an ID, a name, and so on and so forth. Because I've configured this Ktor application to handle content negotiation with JSON, I can simply pass this Pojo object up to Ktor, and it will know how to serialize and deserialize that data. So I'm just going to respond with a list of session data, and sure enough, it translated it over to JSON. And we're able to parse that. So here's what my actual session object looks like. So there's an ID, there's a speaker. Inside that speaker, this is another object. So we get some objects here. Session tags is an array of strings. So we're returning an array of strings here. So very, very straightforward in terms of passing data. What if we wanted to receive data, though? So in this case, I want to get a specific session by ID. So I can define that route with this special parameter right here. And then when somebody calls this route, via a GET request with the ID at the end, I can access that parameter via the call.parameters and then go through and do the work of searching for that session and returning the object form of that session and then responding with that particular object. Okay. If I wanted to post data to this route, I can also do that as well. Same thing. I have just a basic plain old Java class, this data class, hello world. And when somebody posts a JSON object that has a property of hello, I can then receive it inside that call via this generic type, and Ktor will automatically serialize that JSON request into an object that I can work with. Okay. And that's basically all I want to talk about with Ktor for now. Just know it's very, very flexible. If you're wanting to play around with it, I highly suggest downloading IntelliJ, either the community edition or maybe some folks have the ultimate edition. Download the Ktor plugin for it, and then you can see we've got all sorts of features that we can opt into, and this will scaffold out a ready-to-go Ktor project for you. We can even choose what build system we want to use. So notice that this one is using the Gradle build system, but with the Kotlin DSL. I don't get into that much with this talk, but you can do Gradle scripts now in Kotlin using some sort of engine. So here we're going to use Tomcat, and then a whole bunch of features like HTML templating. I know I think WebSockets are in here, authentication's in here, and all sorts of really, really good features. So that is Kotlin from the server side perspective. I'm going to switch gears now and talk about Kotlin from the client side. Okay, so I know I just threw a lot of really big concepts at you, but I just want to touch these little individual points at the very, very high level so we can see the overall landscape. So with Kotlin JS, I first have to talk about this quote from Jeff Atwood. So Jeff Atwood of codinghorror.com is saying, any application that can be written in JavaScript will eventually be written in JavaScript. So he's doing a pun basically on the principle of least power. So this is Atwood's law. So the principle of least power says, pick not the most powerful solution, but the least powerful, which in this case, he's essentially implying that JavaScript is the least powerful language. But all that aside, JavaScript, and I hope everyone can read this slide. I know I'm looking at it on my monitor. It does seem a little small. The key thing is the arrow there at the top. So this is from Stack Overflow, the 2020 Stack Overflow survey that they sent out. And at the very top of the programming and scripting and markup languages, JavaScript is at the top. Okay, so of all respondents and of professional developers, JavaScript is from a scripting language perspective, is very, very popular. And this is consistent. I went back and I looked through 2019 and 2018. This has been consistent for a very, very long time, mainly because, you know, JavaScript is kind of the language of the web. But where it gets interesting is, of the most loved, dreaded, and wanted languages, JavaScript is still very, very high, still in the top 10 of most loved languages in 2020. But I should note that, go back to my previous slide. There we go. So I should note that Kotlin is still at the top there, number 4. So Kotlin is very, very popular, and so is JavaScript. And this too has been consistent in 2019 and 2018 as well. So it behooves Kotlin to, at least if they want to get into this front end game, to at least consider how they might play with JavaScript, or at least operate within the JavaScript world. Okay, but there is a huge problem. Okay, Kotlin is a statically typed language. JavaScript is not. So how does Kotlin go from being this statically typed language and doing away with all of that while still giving you the features that you would expect from the Kotlin language? Well, it turns out this problem has already been solved by a lot of other products, right? So this is the space that Kotlin's competing in. It's competing in the CoffeeScripts, the TypeScripts, the Babels, even Dart to a certain extent. This area where they enforce their own rules about their language, but produce valid JavaScript code. So they're transpiling and emitting JavaScript code based on their languages, okay? Now, a lot of people might not know this, but when Kotlin was in its very early days, they were thinking about this. So bundled away with the Kotlin tools was this Kotlin C-JS command. And this is the Kotlin JS compiler. It's been available since 1.1, and I know Kotlin 1.4 just got released, okay? And its job is to take Kotlin code, validate it, make sure it's valid Kotlin code, and then produce JavaScript code. And that can seem a little weird, okay? But so their goal was to output readable JavaScript code, but also JavaScript code that is optimal in size. And we can get into debates on whether or not they succeeded in that. It's still going from one language to another. It's still producing code. So so let's take a look at it from the readability perspective before we evaluate the optimal size. But one important thing is Java, they wanted to be interoperable with existing JavaScript module systems. So they're not just going to emit just JavaScript code. They're actually going to put some thought into it before before you start consuming it from the web browser. So JavaScript has these module systems that help manage JavaScript from a browser perspective. Okay, you can do just plain old JavaScript, and it'll wrap your JavaScript code inside of its own little module, right? But if you wanted to, say, interface with Node.js, you can also have the option of emitting code that fits the common JS style, which is how Node.js and NPM work with this common JS style. Or you can emit asynchronous module definition, or AMD, which is a module system that's used by Require.js. Although I haven't been in the web world much these days. Is Require.js still very, very popular? I could be dating myself right now. Or aside from Require.js, you could do the unified module definition, UMD, which is a universal pattern that's both supports AMD and common JS as a module. So you have these options from a command line perspective when you're consuming or when you're emitting JavaScript, or when you're passing your Kotlin code to the Kotlin JS compiler. Okay. So in this example, I've got just a basic function. I have this main with some arguments. That's just the default. And then I want to use the Kotlin print line to just print this hello JavaScript function. We're going to send that into the Kotlin compiler and specify the output's going to be this hello world JS. And what gets produced it's a lot of code. It's when I first looked at it, I'm like, wow, that is not very readable. But when you actually stare at it for a little bit, you can see that this part right here is our code. Okay, so we do have a function. We are still using print line here, even though JavaScript developers might be a red flag for them. There is no print line in JavaScript, but Kotlin, the Kotlin standard library, is including a version of print line, and it's within this. This prototype right here, okay? It wraps this console.log, okay? So Kotlin's doing a little bit to help you read both in JavaScript and in Kotlin. So the next step is to include this JavaScript produced by the Kotlin compiler in an HTML page and see what happens. And one thing that is going to happen is you're going to get an error loading just your file alone. And the error says that it's missing the Kotlin dependency. And this exists in the Kotlin standard library, which does exist on your file system when you download the Kotlin compiler. So what we would need to do is we would need to find that standard library, the JavaScript file, copy it over, and include it on our HTML page. But that gets to be a little tedious, especially if you're trying to maintain a production app, or if they release a new version of the compiler, you have to make sure that you're grabbing that each time. So what I would recommend instead is to utilize, obviously, our tools, our IDEs, in this case IntelliJ. And when you do a build in IntelliJ, here I've got a module. So hello.js is my module, and inside there I've got this main.kt file. When I build this, it's going to run it through the Kotlin CJS compiler, and it's going to produce my Kotlin code. So this is my code in JavaScript, but it's also going to bundle away the Kotlin standard library here. It also produces some meta information here. This is just meta files for the compiler. We really don't need those, and I ignore those. So, But when we include both of these files, now when we run our application, we can actually see it's using the console.log to log JavaScript. Okay. So now we're in this world where Kotlin and JavaScript can talk to each other. So now the folks at JetBrains kick into high gear their thought process of interoperability between JavaScript and Kotlin. Okay, and the first thing we can do to get Kotlin to talk to JavaScript is we can just tell JavaScript what we want to do. So in this case, I have a JS function. So this comes with Kotlin, and whatever I put inside this JS function is what's going to get emitted on the JavaScript side. So I can just put raw JavaScript commands in here as strings, and that's going to get emitted. And sure enough, from the front end, that's what gets emitted. So I'm just doing a console.log here, and that's what gets emitted in the JavaScript code. Okay, but you really using magic strings to emit JavaScript code sounds a little strange, and yeah, don't do this probably in production unless you know what you're doing and you really have to. So what you would really do in some cases, you know how JavaScript has these external dependencies on like the browser. So the browser has an alert function in it for making pop-ups, and this is useful for a lot of JavaScript developers, including for doing things like debugging, for instance, right? So what we can say here, if we want access to such a function, is say, hey, Kotlin, I know this function alert is going to exist in the browser, and it's going to be available to me before my code executes. I know it exists. Trust me on this. I'm just not going to define the body of it. This is kind of like an interface contract. So I'm going to say, hey, this is an external function. There's no library that JetBrains is providing for me. It lives outside of JetBrains. It's a function that accepts a message. In this case, this is Kotlin's object. So any is the base class. So it can accept any object, a nullable type, and return unit, which is void, nothing. Okay. And here I can just call this like a function, and when it gets emitted to JavaScript, it behaves just like alert normally would. Okay, but even then, that is a little strange. We want to do things like, how would we access the window? How would we do a redirect? Well, it turns out a lot of those libraries and those functions are wrapped, and JetBrains does provide those for you. So inside here, we've got an external function saying, hey, this window is going to be declared, I'm sorry, an external object that's going to be declared in the browser for me, but it conforms to this window object which they provided me in this this wrapper. Okay, and this window behaves more or less like you would think it would in terms of window.document.location. You get these properties for free. Okay, and location could be a nullable type, so we use the question mark operator, but this behaves just like what you would normally think of as a redirect. Okay, but because the way JavaScript works, we have the prototyping system, we have files that are being downloaded asynchronously. Because of that system, we still may need to turn off type checking. Objects may get bolted onto classes may get, objects may get bolted onto classes just at any given point in time. So in order to facilitate that world, we need to turn off Kotlin's type checking, and this is where we get into the dynamic type. And this just basically says whatever you type right here, that's what's going to get emitted. It's not going to throw a compilation error. It's just going to emit this and just let you do whatever you want to do with this. Be careful with this though, because you could get into, because if that object isn't there, you're still going to run into an error, right? It's not going to save you from that. So that's Kotlin calling JavaScript, but JavaScript calling Kotlin we can do by accessing the module that we've defined our functions in, or defined our classes and functions in. Okay, so here I have in my Kotlin code in IntelliJ, I built a my module module, for lack of a better word, and inside there I've got a file that contains this function called foo, and I can access it by just calling my module.foo. It's wrapped this function inside of its own module. Okay, but if you're if your function was like buried away inside of a package, for example, you would need to access it from the module side and then the package name. So that can be pretty namely to get to that function, but it's still doable. In terms of calling classes, you still get classes. Oh, I'm sorry. So what I'm meaning here is if we wanted to do things like overloading, which we can't do in JavaScript. JavaScript does not support overloading. We have to kind of trick the compiler a little bit. We have to say there's an annotation here that says, hey, I know I have two functions here, one that doesn't accept a parameter, one that does. Emit this one with a different signature. Emit this one with hello with greeting, and then you can get around being able to overload functions inside JavaScript. Okay. So getting this set up, we can use Gradle to be able to build these kind of projects. And JetBrains provides a plugin that lives in their jetbrains.kotlin.js package. This was just released. This was just changed. They're trying to consolidate some of their more front-end plugins into their Kotlin org. So here we can say, using this Kotlin plugin, we're going to define some specific targets. Okay, we're going to build a Node.js project, or we're also going to be able to run this on the browser. Okay, and then for our source set, for our main application, we can also use dependencies. Okay, so here we're going to say, hey, this project is going to be dependent on the Kotlin standard lib for JavaScript, but we also would like to use npm for specific dependencies, like in this case, React. And the Gradle plugin will download and install these packages for you via Yarn. Okay, and also it includes a headless browser for you to do things like karma tests and run tests against your code. Where I see Kotlin.js being used in the market right now is in the React space, actually. So React is a library from Facebook that's used to create user interfaces. I think of React as the view layer in MVC, right? But with Kotlin, it allows us to have some concrete types, right? It allows us to build like classes and things like that in a more Kotlin-esque way. Okay, Dave Ford, who spoke at Kotlin Conf, was very involved in this community. He was on the Talkin' Kotlin podcast with Hattie. He's also spoken at Kotlin Conf a bunch, and he's got some really great stuff out there. Let's see, it is 3:23. I think I'm running pretty low on time here. So I'm going to skip this Kotlin.js React example. This is what it would look like in JavaScript to do Kotlin.js. And then you would obviously use the markup. I'm sorry, this is JavaScript. This is Kotlin.js. And you can see that we're using the HTML builder classes for that. Okay. So there also exists a create React Kotlin app, which is a command line that you can use to scaffold out a React Kotlin app, and it's provided by JetBrains. It works very similar to just the create React app that's provided, I think, by Facebook. So check that out, and you can get up and running with Kotlin.js React really, really quickly. And in terms of wrappers for things like React or styled components or jQuery, there also exist wrappers for that too, so you can get some autocomplete when you're trying to work within those systems as well. Okay, so moving on to Kotlin Native. So we've talked about server-side VM-based Kotlin. We've talked about the front end with Kotlin.js. This Kotlin Native is the world of Kotlin without a VM. Okay. It is LLVM backed, so low-level virtual machine, which is very similar to how Rust and Swift and Objective-C works, but it supports two-way interoperability. So you can talk to C, C++, and C and C++ can talk to you because it's going to be generating those headers for you, okay? And on top of this, it can produce both executables and libraries and frameworks to be consumed by Objective-C. So real quick, so you have your source file, you have your Kotlin code, you're going to run your code through the Conan C compiler, okay, which is going to emit some LLVM intermediate code, and then that code is going to get piped into the LLVM backend and produce binary code for a specific platform. Okay. So what platforms are supported by Kotlin Native? Well, at this time, a lot. You can do Android, native Android. You can do Windows. You can do Linux, WebAssembly, Mac, and iOS. And this is going to be very important for us later on down the road when we talk about sharing code between Android and iOS. So to get started, download IntelliJ. Make sure you're on the latest tooling, which actually I think this slide's out of date because I think it's 1.4 now. Or you can also just download the compiler yourself and just run it through your command line. Okay, I have a sample here. I don't know if I'll have time to run the sample. So so here we have just basic Kotlin code. We've got a function main with a print line saying hello, and this is also a top-level function, and it returns hello Kotlin Native. When I send it through the Conan compiler, I pass it my source, and then I specify my entry point. So this is within my sample package, and then the main function. And well, I have a video of it running. Basically, when it runs, you can just execute it on the command. Actually, let me see. I've got my terminal. Hopefully, everyone can see this. I know I have a very small font. Looks like nano sample.kt. So here is my my code. It's very simple. It's just print hello Code PaLOusa. And if I run Conan C sample.kt and then specify my entry point as sample.main. Oh, I forgot to specify my output. I think my output's just going to be program.kexe. Give it a sec. Oh, it's taking way longer than I thought. Go, 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 go. There we go. Okay, so if I do ls-la, ls-la. So you can see right here, we've got a new program.kexe. So this is a Kotlin executable. And I can just do program kt, and there's my hello Code PaLOusa. I might as well do this other sample too while I'm here. Sample OpenGL. So inside this code, I've got some OpenGL code to be able to draw like a 3D object inside of a window. So those that are familiar with like OpenGL, you know, we have to reference those libraries just like headers. And usually you would do OpenGL with like C, C++, or even Java. You can use the wrappers for Java. But here, Kotlin and JetBrains have provided me with the interop for being able to talk to OpenGL. So in this example, I think I just overwrote my program.kt. I think I did. So if I run that program, so this is my new executable from OpenGL. Actually, let's take a look at that real quick. It's going to be, for those that don't know OpenGL, this may be a bit unreadable. So yeah, so here we're doing things like GL push matrix, GL translate, GL rotate. Like those are all GL commands that are operating on an image, right? And program KEXE, and that of course launched on that side. So here is a 3D renderer using Kotlin and OpenGL. Oh, somebody was asking to make the font bigger. Yeah, I tell you what, since that file is so big, I'll just provide that. I'll put that up on my GitHub for you. That way you can see it, because there's a lot going on in that file. It's not really that readable, just other than the GL stuff. So, but we're using OpenGL with Kotlin. Okay, so we're talking to native libraries for being able to do that. Okay. Okay, so I'm through that. So there's Kotlin Native. Okay, so the other thing I wanted to talk about, so when I was producing, when I was running that code through the compiler, I was producing an executable. You can produce libraries as well, but another thing you can do is produce a framework, and you could target iOS or to iOS ARM for if you're deploying to a device or you're deploying to an emulator, and then optionally a directory where to spit out the framework. And what you get is an iOS framework with headers and a plist and an executable for being able to talk to that code. I'm sorry, the header is for talking to the executable. So if we pop open the header file, you'll see a bunch of stuff in here, a lot of Objective-C code, some protocols, and an interface into my code. Okay, so this was my source code. So in here I named my application demo, my sample kate.kt, and here is an interface into the main function that accepts some arguments. This is just a string array, but this is an interop code for me to be able to talk to that executable within, inside iOS. See, I'm so running out of time. So that means at this point we've looked at things from the JVM side. We can talk about things from the Android side. It's not really that interesting because it's still the same as the JVM, but we're doing things in JS and we're doing things in iOS. How do we manage all of these things together? Well, at Kotlin Conf 2017, they announced Kotlin Multiplatform, which is a way for you to define common code to be able to distribute through all of these different platforms. Okay, so here. So we've got some common library code that I want to be able to distribute to all of these different platforms. And how do I manage that code? How does that code get sewn together when it finally reaches its specific target? Okay, so they provide a tool, a Gradle plugin, for being able to define multiple targets, and then you can also define some common code that gets sewn into these different platforms. Okay, you define common code using expect and actual. So these are keywords that you're going to say, hey, I expect this to be there by the time I reach Android or by the time I reach iOS. And then on those various platforms with those targets, you can say, okay, this is my actual code. Okay. Now it's still experimental. They're still working on it. So don't run out and try it. Definitely try it. But just so you know, it's still. I had a lot of trouble getting this working. But also, okay, you may be thinking, what kind of code do I share? Kotlin Multiplatform isn't meant to share all code, just things that you can do commonly amongst all these platforms. So things like data models are a great example. I mean, anything that's not dependent on like platform-specific stuff, data models are good. Validation rules. Network client code is really, really good. And we talked about KTOR and their HTTP client. That is multi-platform code that they've provided. HTML generation, it just becomes string down the road, right? What not to share are things like UI code. Let the platforms do their own UI-centric stuff. You'll have a much easier time being able to share code if you're not sharing UI across different platforms. Don't share RX chains if you're doing RX Java or things like that. There's no such thing as a multi-platform. Well, there is a library, but I don't really want to get into that. You can make things reactive, but like RX Java proper, like you're probably not going to be sharing those things. Threading models, you could arguably do everything in coroutines, but it's not great because iOS is doing their own threading model. Android's been doing their own thing. Probably not something you want to share common between those. And then database stuff. And this is a question. Do you really want, if your JVM code is running on the server and it's dependent on like a MySQL database, or actually, no, that's a bad example. Probably how about a Microsoft SQL or Oracle database, yet your Android code is dependent on SQLite, might not make sense for you to share like any database stuff. So how is this working? So we are going to define our target. We're going to create a multi-platform target that is going to target JVM, say like Android or something, right? And then we're also going to target JS. So when you define a target, you get two source sets. You get a source set for JVM main. So this is where all your JVM code is going to go. This is the artifact that's going to get produced. And then you're going to have a test folder, so you can add unit tests and things like that for your JVM code. And then for JavaScript, you're going to have a main source set for JavaScript, and this is where all your JavaScript code is going to go. Okay, but over both of these, you're going to have a common main where you can actually do your sharing of your code. And as your compilation happens, when it reaches your target, that's going to be your final code that you get. Okay. So in order to get started with Kotlin Multiplatform, this is IntelliJ. This is a Gradle. So we're going to use the Kotlin Multiplatform plugin. I think it's 1.4 now. So but 1.3.2 is or 7.2 is still a very stable version. And inside the Kotlin block, you can define these different targets. So here we have JVM, we have JS. We can also get in there and define, as I was talking about earlier, the different modules that we want to emit. If we wanted to do something for like Node.js, then we've got an Android target that we're going to do. We can optionally give it a name if it clashes with some other target. And then we've got some iOS code. And the output of this is going to be a framework that another iOS app can then consume. And then we start defining what our source code is going to look like inside our source code block. So here we can define things like dependencies. Okay, so inside of our common main, we're going to be using Kotlin, right? But maybe in the JVM, we want to add some additional dependencies, like say we want to use OKHTTP or things like that. So you can get really granular with how you're configuring all of the Kotlin, like by the time it reaches its final target. And so this is what it looks like in IntelliJ. You're going to have a lot of folders and being able to manage code. And what you may be thinking is, okay, if I'm defining like a calculator, for instance, am I going to need code in like the JVM world, like calculator functions? This is using just primitive types. So am I going to need some platform specific logic for this? And the answer is no. By the time it gets to iOS and Android, it's still platform independent. You can have this logic and not need platform specific code. But if you have like a class called like greeting, and inside here we want to say, hey, iOS, or hello, Android, or some sort of arbitrary string, then we would need to define some platform specific code. So what we can do is say, I expect iOS and Android to define their own platform class. And inside that class, there's going to be a property called platform, which they can then populate with whatever string they want for each platform. And then inside each target, we can say, okay, here's the actual implementation of this class and the actual implementation of this property. And we're going to switch between iOS and Android between these two. Okay. And the tooling has gotten really, really good when you start to define these expect classes in your common code. It'll actually say, hey, this class, there's no actual declaration for this inside of this JavaScript module or this JVM module. So it'll go through and it'll validate, okay, you've defined this, but I don't see any actual implementations of this. So the tooling is getting really, really good. And let's talk about that date class for a sec. So if we define, if we expect each target to need like a date class, it obviously doesn't make sense for us to actually write those implementations, right? Like we're not going to rewrite the date class in the JVM world, right? So what you can use is Kotlin's type alias to delegate these implementations, okay? So we can expect a date class, but for each platform, we're going to say, hey, use the Java util date. I'm not going to write a date. Use Java util, or use the JS date. I was thinking of the SQL date for a sec there. I don't know why I blanked on that. So you can delegate those to your own implementations, and that's perfectly fine. That's perfectly legal, as long as they conform to that expect class and have those various properties that you need. Okay. So, and you may be thinking, why would I use expect actual versus interfaces? They're much more flexible. They allow you to define your own path forward. And you can also expect top-level functions, and you can expect extension functions too, and you can reuse implementations if you need to, just like I was talking about with the date. Okay, so there's a great talk from GoTo 2017 where Dmitry Germanov, who's one of the authors of Kotlin, talks about what their intention before this, and he actually goes into a much deeper explanation of expect actual than I do. So that's Kotlin Multiplatform. So who is using this in production right now? So Target is using this right now. I know they've shared some of their networking code doing their models, and I think they're eventually going to be moving to redoing their entire network stack in Kotlin Multiplatform. And you can read about it on this link I've shared with the slide. The Square Cash app is doing a lot with Kotlin Multiplatform right now, both on iOS and Android, so much so that they have produced a library for the community called SQLite. And what SQLite is, I know I kind of gave that little asterisk about sharing database code, but what SQLite does is allows you to specify your SQL statements, and then it will choose the various platforms once you get down to your target. Okay, so for like mobile apps, most mobile apps are using like SQLite as their database store. SQLite will produce valid SQLite code. If you're on the server side, I believe this library will produce MySQL code, and I know they're working on it for various other implementations as well. And I do think they have an implementation working for JavaScript too, in terms of using SQLite. So it's available. I don't know if I would use this though, because I tend to use other ORMs and things like that. So, but it's available to you, and this is one example of where we're going in terms of multi-platform. Apollo is an implementation of GraphQL, and they provide their own implementation, their own library for interacting with GraphQL that works on both iOS and Android. I believe, I think Android is using OKHTTP to make the calls, and then I forget what iOS is using under the covers. And I would be very remiss if I did not at least mention this company called TouchLab. They're doing extensive products and work in the community right now using Kotlin Multiplatform. They're based out of New York, and they are very, very involved with the community and trying to push for this multi-platform world. So miscellaneous things I just wanted to quickly mention, because I know somebody's going to say something. You can do scripting in Kotlin. So kscript is the way you could do like bash scripts and shell scripts and things like that. So you really could do literally everything in Kotlin. If we're talking about scripting though, and creating like little commands for like terminals and things like that, I would point most people to Clicked. This is a library that makes doing command line applications way, way easier, and it's also multi-platform. So you could write a command line application, and it will work on Linux, Windows, so on, and Mac OS, obviously, so on and so forth. So I would take a look at that for doing that kind of scripting. But it's nice that kscript is still available to you as well. And then, as I mentioned before, the Kotlin DSL for Gradle is now available. I haven't used it much personally. I'm not really that big on Gradle, other than managing dependencies and doing the Android stuff. But for those who are really into Gradle, using the Kotlin DSL is really, really nice, because it provides you some autocomplete and some stuff just right there in the IDE for you. Whereas Groovy and Gradle, you kind of have to guess. Oh, Gradle is all within Kotlin. Is all in with Kotlin. Yes, that is true. Yep, they're going all in. So more Kotlin for us. So conclusion, Kotlin is a modern, pragmatic, industry-built language. I've said that many times. It's kind of their tag, but it's really, really true. When you look at Kotlin from a language perspective, if you jump in, it's very, very familiar. It borrows heavily a lot from other languages in its design and how you build applications. Kotlin became popular on the JVM, but there really is this bigger vision to doing things with the language across all platforms. And I personally think I have a soft spot in my heart for like Flutter. I really enjoy the developing experience of Flutter, but from an enterprise app perspective, scaling, I think you can't go wrong with just doing things natively, right? And being able to share code across platforms. I think Kotlin's going to be very, very popular in that space. And they're certainly throwing everything they can at it. So keep an eye out for multi-platform projects. They're going to be very big here in the future. So they're big now. They're going to be even bigger in the next couple of years. So I have a lot of takeaways for you. So obviously, if you're looking to get into Kotlin, go to the kotlinlang.org. They've got a bunch of good stuff, and including with the multi-platform stuff. If you're reading their documentation, they actually specify which platforms each library is good for. So there's a lot of stuff for like JVM and JavaScript, but it'll also tell you, will this work on Kotlin Native? And it'll have a little dot there too. Check out the Talking Kotlin podcast. Hadi's really good. It's a really good podcast. Join the Kotlin Slack group. I'm on there. I'm active all around there. You can find me on there. I like to chat with people and talk about Kotlin. The slides for this presentation I will put up on GitHub. I think these links are maybe out of date. I did update this presentation for 2020 to include a lot of the stuff from Stack Overflow. And I believe my GitHub also has a lot of takeaway resources to some of the research that I've done for this. So take a look at that. And that's all I've got. It is 3:45. I think I am out of time. If anyone would like to chat, I will be here. You can find me basically anywhere. I'm on Twitter. I'm on Slack. I'm not on Twitch. I was on Twitch the other day for the interview, but thank you so much for coming to this talk. I had a really fun time presenting for you, and I know I threw a lot of information out there for you, so hopefully some of it stuck. I appreciate you. So have a fun and fantastic Code PaLOusa.